What do you have there, sir?
Well, these are called tektites. These are actually what's called impact melt. This is actually material that was ejected from a large impact site long ago. Molten material that's resolidified as it fell back through the atmosphere. And some of these actually have sort of aerodynamic shapes, like this one actually looks like a teardrop. And that's because when it was ejected from the crater, it was molten because of the tremendous heat of the impact. But then falling down through the atmosphere, it resolidified into that teardrop shape. So many of these tektites have teardrop shapes and spherical shapes, basically big raindrops, essentially, that resolidified on their way back to the Earth. And so you often find these tektites around big impact craters.
So the tektites are terrestrial in origin? They're not part of the meteorite?
Yeah, they're more terrestrial because it's from material that was excavated from the Earth's crust during the impact. When you have a big impact event, there's so much kinetic energy that's transformed into heat energy that molten material is just thrown everywhere. And so, in fact, much of the interior of the crater itself is melted from the heating. And so this is molten material that is resolidified coming down through the atmosphere. Much of this is from the Earth's crust rather than the meteorite itself.
Now, I am a novice, and I hear the term iridium a lot when it comes to meteorites. Could you explain iridium for us really fast?
Iridium is a rare metal. It's rare in the Earth's crust. It's a heavy metal, and most of the heavy metals have sunk down into the Earth's core, so you don't find them in great abundance in the Earth's crust. But they're much more common. Something like iridium and also platinum are more common in meteorites. Iron meteorites specifically, because iron meteorites come from the cores of asteroids. And again, those heavy metals would have sunk down to the cores of those asteroids. And when those asteroids collide, fragments are produced, and so that's how we get, the insides of asteroids right here on the Earth in the form of iron meteorites. But a typical iron meteorite will have a much larger abundance of these heavy metals than what you find in the Earth's crust. And that's the cosmic connection with the dinosaur extinctions. There's a layer of sediments stretched across the Earth that dates back 65 million years, about the time the dinosaurs checked out. And that layer of sediments is highly enriched in platinum and iridium, and in about the same abundance as you find in meteorites. So that's one of the main pieces of evidence that connects the dinosaur extinctions with an asteroid impact.
Excellent. Thank you.